Hi and welcome back. I'm going to do two more examples regarding the properties that we have seen before, the property of a multiplication and the property of a division as well with functions, okay? I'm going to use my favorite book to name the example, and we're going to have function y equals x squared cubic root of x squared, okay? Again, y equals x squared cubic root of x squared. First thing that you have to ask yourself when you see a problem, okay? Just don't start right away writing numbers. Just look at the problem and see what's being asked to you and see what's being handed to you, okay? What do we have right here? Do we have one function or do we have two functions? Do we have a product? Do we have a division? Do we have an exponent? Do we have a trigonometric function? What is it that we have? Well, if you take a look closely, you're going to see that we have two functions. Product, as a matter of fact. Function number one, f, we're going to call it x squared. Function number two, cubic root of x squared, we're going to call g. So we have f times g, or a product of functions. Okay? Now, do you recall the property of derivative of product of functions? Well, we can do it right here real quick. F times g, derivative is prime times g plus g prime times f. Okay? And that rule is exactly what we're going to use right here to solve this exercise. There's another rule we're going to have to use as well, but it's pretty much familiar by now for you. And is, once again, k x over to n equals kn x n minus 1. Okay? Remember what we said in a past video? When you have something that is expressed in the way b root x power to a, this is equal to say that we have x power to a over b. Okay? So this we're going to use for this g function. Okay? So we have y prime. It's going to be equal to x squared prime times g and I'm going to play a little bit with the expression just to make the exercise interactive. Plus g prime times f. Notice that I played with g. I expressed it in two different ways in the same line. Normally you shouldn't be doing this. You should be a little bit more consistent with the way you're expressing g. But I'm just doing it for the sake of the exercise and for the sake of letting you know that I can do both ways. And it's still the same function, okay? Normally you should do either one way for the whole line or the other way for the whole line. You shouldn't mix them, okay? It's not really elegant. But I'm doing it only to show you that it's the same thing, okay? So y prime is the derivative of x squared is 2x. 2 goes down, 2 minus 1 is 1. X power to 1 is x. Times, let's keep this method, okay? X 2/3 plus derivative of x power to 2/3. 2/3 goes down, x, and then we have 2/3 minus 1. 2/3 minus 1 is 2/3 minus 3/3. So it's minus 1/3. Multiplied by x squared. Okay? We can even draw a few arrows so you can see what happened right here. I've just executed the derivatives of f and g. Right here and right here. Okay? And now all we have to do is simply simplify. Simply simplify. That sounds kind of fun, right? Y prime equals 2x times x 2/3. Now here's something interesting, okay? 2 times. When we have x, the same base, but different exponents, what is it that we have to do? Well, we just add the exponents, okay? And we can write that so that here, okay? When we have, say, x a times x b, this is equal to, say, x a times b, okay? So in this case, we have 2x powered to 1 and x powered to 2/3. So we have 2x, 1 plus 2/3 is 2/3 plus 3/3. So it's 5/3. Plus, same case here, 2/3 x powered to minus 1/3 times x squared is x a plus b. So minus 1/3 plus 2 is minus 1/3 plus 6/3, because 6/3 is 2. So 6/3 minus 1/3 is 5/3. And whoa, look at that. We can even do a common factor right there. Let's do it in the next line. Y prime equals, we can do 2x 5/3 common factor of 1 plus 1/3. Right? No, but that sounds kind of fuzzy too. We can even operate this too. 1 plus 2/3 is 3/3 plus 1/3, so it's 4/3. And we can even do 2 times 4, which is 8, and the 3 remains the same. 8/3. After simplifying, there you go. There is the solution of the problem. Let's go over it just one more time. The function is x squared times cubic root of x squared. As I said before, when you have root of b, x power to a, it's the same thing as saying x power to a over b. And the rest is just the derivative rules, okay? So we do y prime, derivative of a product. First derivative, 2x is the derivative of x squared. Second one without derivative, x power to 2/3, plus second derivative, which is 2/3 x power to minus 1/3, times the first function without derivative, x squared. Simplify, x 2/3 plus, times x 1 is x 5/3, 2 plus, again, 2/3, x minus 1/3 times x squared is x 5/3. Add, simplify, everything else, and there you go. There is the solution.